No, I didn't touch the water.
Dang. I bet I'm good. I didn't. Holy cow, Connor, you have a lot of beans. Well, a lot of it.
Okay, so you put your calculators down.
Your freshmen are.
Idiots.
That's a word.
Yeah.
Yeah, I got you. Okay.
So did you all three have messages on yours?
No. I got a message on mine. Sometimes I have a message on mine. Oh, I should use my network.
No, don't leave a message. I'm gonna yell at them.
Well, I was gonna leave that message. I was like, how can I type?
What if I had like turn on like a secret reminder?
Don't leave messages for the freshmen either. Okay?
Is your next hour freshman?
Yes. Please don't. Because if they have to clear their calculator every day, then it erases the program that I gave you, and you don't want that to happen. So don't be a bad example to them, and then I can yell at them. It'll be all good. Okay, so a little bit of information for you. Okay, we are finishing lesson 6.3 today. It is not super difficult. It's all formula based. A little bit of logic in there. Tomorrow will be our last section in this chapter. So on Thursday, you're going to get your chapter review. Yeah, we'll be done. This is a really short chapter. So just so you know, tomorrow's our last section in the chapter. But obviously, we're not taking our test before that, before spring break.
I just
Okay, first thing, I want you to know 45 minutes. 45 minutes on Thursday. That's what I was told. Don't know if it's true, but that's what I was told. There's another way to write vectors. So if you, and the only reason I'm telling you this is because you have to be able to read it. You do not need to know where it comes from and how we got it, because I'm choosing to skip that stuff because I don't like it. So if vector u is 4, 5, you might see it as a homework problem. So not on the test, not on a quiz or anything else, but just so that I could use a homework problem. It could also be written like this. So with i's and j's, when you see the i's and the j's, don't freak out. This is just the delta x in the front, and this is the delta y. So you can real quickly use it, like know that it's component form. Okay, so I'm only telling you that because on your homework, it's going to be like, hey, find the magnitude of this vector. Well, translate it back to the components that you know. Okay, so these are your numbers. This is your x, this is your y. No, like that's not weirdness. I mean, it's weird. It's just not difficult. There's something called the unit vector that we're not talking about that gets into some pretty nasty stuff that I didn't want to do. I thought I would keep this chapter easy. So we're not doing it.
I agree.
Okay. If you really want to know, you can read the book because it says. Okay, so what we're going to talk about today, the first thing we're going to talk about is the direction angle of a vector. And this is where we get a little bit, I'm going to have a little bit of trigonometry involved in here. So this is where the connection is, says we haven't had any trigonometry in our vector stuff so far. And so this is where we get that overlap. That's why it's in this chapter. Oh, stop it. Okay, so let me show you an example. So let's say this is our vector here. Okay, so it ends at this point. This is vector u. The direction angle of the vector is normal direction, like normal trigonometry like we talked about. We're not talking navigation or compass bearing. We're just talking about the angle from 0 degrees out to the side. Yeah, like 47. So that's the direction angle. So we have a formula to get that. The direction angle of a vector on your pink paper. Direction angle of a vector is tangent of theta, which is the direction angle, is equal to delta y over delta x. Okay, so I'll give you an example. This is not difficult math. There's a little bit of use your brain in here, but other than the use your brain part, then you're going to be fine. You're cooked. Okay. Not Trevor necessarily. So let's say this is actually vector u and it is at the point 4, 5. So the way that we find the direction angle is we do tangent of theta equals delta y. What's the delta y? 5. And what's the delta x? 4. And so how do we get theta from that? Yes, you do tangent inverse. Make sure that you're in degree mode. Probably you are, but okay. So theta is equal to what? Yeah, pretty easy, right? So here's where the thinking comes in. Okay, well, let's say that u is negative 712. Why don't you find the direction angle for negative 712? Okay, so this is what we're going to talk about. Yep, we're going to talk about the funkiness. So you should get negative 59.74. Here's the deal. If you graph this vector, negative 712, you don't have to graph it beautiful. Some of you are going to be able to do this without graphing it because you're going to be able to think about it. Negative 59.74 is actually in this quadrant. This would be negative 59.74 here. Okay, and so you have to think about this. I want you to think about when we did tangent inverse, remember that when we do inverse tangent, the answer comes from this half of the graph. So your answer will come out as being in the first quadrant or the fourth quadrant. You have to use your brain, that's where your brain comes from, and figure out what's his actual angle. So please observe, this is a geometry property. If this angle is 59.74 degrees here, this angle, which is directly across from it, is called a vertical angle, 59.74. Now, remember then that your direction angle starts at 0. So how do you figure out the actual direction angle? Okay, so yeah, 180 minus 59.74. Okay. Yep.
Just like add 180 to negative 59.
Sure. Is that going to work every time?
I don't know. You tell me. That's my master.
You got, well, did we add 180 up here?
No. But we weren't negative.
Okay.
That's what we're saying.
If it's negative, can you add 180? Yes.
Okay.
Okay.
Work always if it's just negative.
Yes. I think about that. Yep. I don't want to tell because I don't want to tell you yes if it was a potential to not work at some point in time. That's why I have to think about it. Okay. Now, once you find the direction angle for u is equal to negative 8, negative 10. Oh, yikes.
Just work it.
What do you get for, you should have tangent of theta is equal to negative 10 over negative 8. What do you get for theta? Guess what? That's not correct either.
No, because we're in the fourth quadrant.
We're not in the fourth quadrant. We're in what, Eli? We're in the third quadrant. We're back here, negative 8, negative 10. So what am I going to do with my 51.34?
128.66.
You're going to add it to 180
We're adding.
because this is the 51.34 down here. So you got to add 180.
Oh, you're gonna.
So I guess here's what I want to say.
So we are adding negative. So you're at positive.
Okay, 2 negatives puts you in the third quadrant. Add 180 to get your correct angle. Last one. So let's say I want the direction angle for U is equal to 4, negative 7. Okay, so if tangent of theta is equal to negative 7 over 4, what do you get? Okay, so you get negative 60.26. So that's here. Right there would be negative 4, negative 7, or 4, negative 7. That's not drawn to scale. This is negative 60.26. What's this direction angle? So your direction angle has to start at 0 and go all the way around to the angle.
Is it 360?
360 minus 60.
Yeah. Yep, there you go, 299.74. Because you guys, this all makes a whole circle, right? The purple arc plus the reddish arc, that makes a full circle. So take your 360 and subtract whatever you got. So my point to you on the direction angle, be really careful of what quadrant you are in. Okay, if you need to draw a picture, draw yourself a quick sketch. Okay, a lot of people are visual and you need to see what's going on in order to figure out what to do. Okay, if you don't want to draw the picture, don't draw the picture. I don't care, but that's my recommendation. First quadrant is normal.
First quadrant's normal. Second quadrant, you add 180.
Third quadrant, add 180.
Oh, sorry.
Correct.
Opposite. Second quadrant.
Second quadrant, add 180.
Add 180.
Third quadrant, add 180. Fourth quadrant, add 360.
Yeah.
Right? Or because you're subtracting that number from 360. Okay. We're going to write down the formula before we write down anything else for this. So vector
Now I understand it.
A vector is a mathematical quantity with both magnitude and direction. Yes. So when we get in physics or whatever, when we get information with magnitude and direction, we want to be able to convert that to components. Because once it's in components, we can add it, we can subtract it, we can multiply it. It makes life a lot easier. So here's your formula. So delta x is the magnitude times the cosine of theta, and delta y is equal to the magnitude times sine theta. So those two formulas are how we will convert magnitude and direction to components. Now, here's the good news. This magnitude of a vector, like in a story problem, that's given to you. So is the direction. So you don't have to find it. You just are going to use it. Okay, so let me give you an example. Okay. So let's say that we have an airplane descending. Not going to be able to draw an airplane. Kids can't draw airplanes. Your airplane's coming in for a landing, descending 30 degrees below the horizontal. Yep. So we're going to call it a 30-degree down angle to the west at a speed of 200 miles per hour. Okay, what we're going to do is convert that to component form. So the two things that we need are an angle, so we need theta, and we need a magnitude. Here's the good news. If you have speed, that's magnitude. Okay, so that's going to be the absolute value, or not the absolute value, that's the magnitude of v. So in our formula, speed is 200. That's what we're going to care about here. That's 200. So the question I have for you is, what's the angle? Why? Yeah. Here's our angle. Remember our direction angle? So just like what we were talking about, direction angle starts at 0, not at north, because we're talking direction angle. That's different. No, that's a lot of confusing things. If this is 30 degrees below the horizontal, then it's 180 plus the 30. So our theta is 210. So we know that our magnitude is 200 and our theta is 210. And then it's just a matter of putting those both into the formula. So delta x is magnitude times the cosine of 210. And delta y is 200 times the sine of 210. Okay, what's the delta x quantity? 173, you said? Okay, and what's the delta y quantity? Negative 100. Now, as a check, you should have something that pops you into this quadrant, right? Like negative 173, negative 100. That's probably right. Like, if you got a positive 100 or a positive those two things, you'd be like, oh, I got something wrong. Probably it's the angle because the magnitude is pretty easy. Okay, so let's do that again. But let's say our plane is ascending at a 40-degree up angle to the east and a speed of 150 miles per hour. Okay, 40-degree up angle to the east, speed of 150 miles an hour. Please convert to component form. Okay, so what's our theta that we're going to use? Yeah, that one is what it is, because if we're going east, that's to the right, and we're going up at 40 degrees. So that is his direction angle this time, and our magnitude is 150. So we have delta x would be what? I guess I'm going to write it like this. So delta x should be 150 cosine 40, which is what? 114.9. And then delta y is 115 sine 40, which is what? 14? 42? Okay. Oh, geez. 42. Got it. Okay.
Why is it 115?
What did you get?
It's 150 sine 40. He's just talking
Oh, this, because I screwed up. That's looking at this. Okay, questions on that? Now, the last thing, and I will tell you, this is test extra credit. So I want you to write this down. Example 11 on page 430 is going to be your test extra credit, which I realize we're now talking like 3 weeks from now, because they got spring break in there, 2-ish weeks from now. But we're not going to do that. We're not going to do that problem, but that's what it's going to be like. That's the kind of problem I'm going to give you for extra credit on the test. What I'm going to show you now is how are you going to do that? Okay, so you have one of these on your homework tonight. So let's say that we have these two vectors. So we've got this guy, 25 degrees with magnitude 400. And we've got this guy, and he is 135 degrees with a magnitude of 300. Now, I want us to add them together. Huh? Indeed. So listen, this is not as hard as you think it is. Okay? How do we add? This is a 300. If you're looking at it, looks like 360, but it's 300. Okay? If we want to add vectors, the easiest way to add vectors is to put them into component form, which we just learned how to do. Okay, so let's go. I'm going to color code. Let's go with the green vector. The green vector delta x is going to be what? How do we find that? What's the equation I put in my calculator? (400 cosine 25). And delta y is going to be 400 times the sine of 25. Okay, what is the x? Yep, 362.5. And then what's y? Yep, 169.05. There's the green vector. So all we got to do to add is we're going to put them into component form. Okay, now let's do the same thing with the purple one. So his angle, if you can see it, I know it's a little small, his angle is 135 and his magnitude is 300. So you find that vector, purple vector, delta x, delta y. Okay, what's that delta x? Yep. So negative 212.13. What's the y? Okay, now that they're in component form, we can do whatever we need to do with them. Okay, so we want to add those guys. Now, this term is in your homework. When you add two vectors like this, two vectors with their magnitude, it's called the resultant is the answer, which should make sense. It's just the result. It's just a fancy word for result. Okay, so what do you get for x? Yep, 150.37. What do you get for y? Yep, 381.18. Okay. Now I can do all kinds of things. First of all, let me show you this. You don't have to do this, but if I was going to add these vectors, I literally would go head to tail with this. I would say, okay, this guy is an angle 135, magnitude of 300. Okay, you do not have to do that. I'm just letting you know, you don't have to do that. But we can now find his magnitude because we have a formula for magnitude. And you can find his direction angle, which you're going to have to do on your homework, but I want to give you homework time. So you have formulas for all of these things that you have. Okay, everything that you have to do is formula based. So component, magnitude, direction angle, and converting, all formulas. So here is your homework.
I remember.
Okay, listen carefully. You do not have to do any graphing today. So even if it says to graph, you don't have to graph. Okay, you do not need to graph today.
That's all I remember.
Ooh, nope. 95 and 96 are not correct. Yeah, just 97 right there. There you go.
I'm gonna upset her.
So she kicks you out anyway?
Yeah. I don't care. I'll go to the office. I'll probably get more work done there.